Okay, so I'm going to do number 1 in our classroom exercises. And here we have a circle, we have the center of a circle, and it looks like we have a right angle. So it almost looks like a clock that says 3 o'clock. And we are told to find the length of the arc and the area of the shaded sector. And the sector we're looking for is this sector here. So that area there. So, we know we have a right angle, so the measure of this arc is 90 degrees. If the measure of that arc is 90 degrees, we know that we have 1/4 of the whole circle. Let's actually first find the circumference and the area. So the circumference of the circle is equal to 2 pi r. R is 1, pi is pi, and 2 is 2. So 2 pi r is just going to be 2 pi. Now, because we have 90 degrees out of 360 degrees, we're going to write that ratio, and we're going to multiply that by the circumference, which is 2 pi. Now, note, you can include that in the equation, so you could include the 2 pi r in your equation, like we wrote out before, or you can do it separately. I like to do it separately, but you can do whatever works for you. So this becomes 1/4 of 2 pi, which becomes pi over 2 when you simplify. Now, let's find the area of that sector. I'm going to first find the area of the whole circle. So the area of the whole circle is pi r squared. Pi is pi, r is 1. When you square that, you get 1. So it's pi times 1 squared, which is equal to just pi. And once again, I know that I have 90 degrees out of the 360 degrees, making up that sector. That's my central angle. And so when I multiply that ratio by my area, which is pi, I get 90 over 360, which is 1/4. So it becomes 1/4 pi, or pi over 4. And I don't care if you write pi over 4 or 1/4 pi, whichever way you like, it'll be fine. I think pi over 4 might be technically a little bit better. It's a little more condensed, but you can choose what you want for right now. Okay, with that, let's do number 3 as well. So, my camera blanked out for a moment. There it is. Okay, number 3. We are given another circle, surprise, surprise, with a radius of what appears to be 4, and we have a 45-degree arc measure right there. So, I'll do this one by including the circumference and area equations into my equation. So I use just one equation for each of those. So let's see. We're looking for that area there, and we're looking for the measure of that arc there. So let's find the measure of, or the length of that arc first. See, I switched measure and arc. Let's find the length of that arc first. What that is going to be, it's going to be, let's see, length of arc is going to be equal to 45 degrees divided by 360 degrees, so that proportion of the whole pi, 45 divided by 360, and we're going to multiply that by what our equation is for the circumference, which is 2 pi r. So times 2 times pi times r, and our radius is 4. So this gets us, see, 45 divided by 360 is actually 1/8. You could think of it as it's 1/2 of 90, and 90 is 1/4, so 1/2 of a fourth is 1/8. So it's 1/8 of, let's see, this multiplies out to 8 pi, and it looks like our numbers are going to work out very nicely there, where the 8's cancel out, and we're left with just pi. So that is for the length of that arc. Now let's find the area of that sector. And it's going to be a very similar looking equation where we have our proportion, 45 degrees out of 360 degrees. And we're going to multiply that by the area of the whole thing, which is pi r squared. So times, that's a times pi, and then r squared, we have 4 squared. Now 4 squared is 16, and 45 over 360, once again, is 1/8. So you have 1/8 times 16 pi, and 16 divided by 8 is 2, so we're left with 2 pi. And those are our answers for number 3 of the classroom exercises. Alright, I'm going to give you just one more note. This isn't a classroom exercise here. This is one additional note for you all. And it is a type of problem that you're going to encounter in your homework. And it is where you have a region that you have to find the area of that isn't a sector, but you have to use the sector to find it. And I think example 2 on page 453 is like this. So let's say you have a circle and you have a sector. But rather than find the area of the whole sector, you're asked just to find the area of this little piece here. The way you would go about finding that, and this is just a general strategy, is you would use your area addition postulate, where you know that the sum of this triangle plus this weird area is going to have to equal the area of that whole sector. So say we knew some angle measures here and we knew the radius. We could find the area of this triangle, find the area of the whole sector, and then subtract those to find the area of that little piece. So you might have to get creative in the way you solve some of these problems, but you have all the tools in your toolbox to do it, so you can be encouraged by that. So that is all that I have for right now. I hope that you enjoyed this lesson and have fun doing your homework.